Well, thank you so much for the invitation, for coming today, for the introduction. Yes, Italian still works, so we can go switch also to Italian in the discussion if you prefer. So today I will speak mostly about not really Copernicus, but about what was going on around Copernicus. I have to sit because I got the light exactly in the eyes. What was going on around Copernicus, and especially around the publication of Copernicus' book in 1543. So the talk will conclude exactly in the year 1543. What I'm going to present today comes from this project, the SPHERE, Knowledge System Evolution and the Shared Scientific Identity of Europe. It's a long-term project in computational history where we have several general research questions. I will mention some of them during the talk. But one thing is important to understand is what we do in this project is not really studying astronomy. SPHERE is about astronomy, this sphere. Not really studying astronomy in the sense that I look at, I don't know, Copernicus' book or Kepler and Galileo and so far and so on. Of course, I did this too, and I will do this as well, but this is not really the goal of the project. The goal of the project is more to see what was the astronomic culture and knowledge that was circulating all over Europe, let's say for the potential readers of those books, of those people. And so it is a difficult question to define historically, and a way to cut it down to something more precise is to think about the students at the university. Which kind of astronomy were the students learning at the university? So these, if we go in this direction, then we have a way to define which kind of historical sources we can take to analyze them. And these historical sources are the textbooks used at the university. It is a project in computational history because we have collected lots of them, and the amount of material. I have a kind of echo coming from me here. I don't know. It's a bit. Okay, yeah. Maybe we switch a bit down. We go a bit down with the volume. Yeah, we could also analyze this instead of speaking about Czechoslovakia. And so the kind of material we have, it's textbooks. It's a lot of them, and that's why it becomes a project in computational history, because it exceeds the capacity to read everything alone, but even with other people. And so here a little bit of numbers, some numbers. So we collected we have four collections of textbooks. We have the collections of textbooks that contain the sphere of Johannes de Sacrobosco. This is the most used book from the 13th century until the 17th century to introduce students to astronomy in all over Europe. The textbooks were almost never made of just one text, just one scientific work. They were made of many texts. So when you find the sphere of Sacrobosco in a textbook of the 15th century, 16th century, but also earlier in the manuscripts, you always find it together with other books on astronomy that deepen certain aspects. Let's say the sphere of Sacrobosco was a kind of general introduction, and then you see the deepening of certain aspects, and what we investigate is which kind of subjects were deepened, were becoming more and more important over time. So we collect, and then we have other three collections. One is all the textbooks that contain the sphere of Pseudo-Proclus. Then we have the Theorica Nova of Feuerbach and the Old Theorica. So these are the four texts around which we made our collections, our corpora. In total, we have 477 editions, or different editions of textbooks from 1472 until 1650. If you take an average print run of 1,000 copies, Gingerich says it, and nobody has complained about that until now, then it means that we are speaking about 450,000 books that were circulating in Europe in this period. For us, it's about 100,000 pages of material to analyze. You see also the geotemporal distribution of this stuff. Okay, so what you see here is what we have done with these books. We have dissected these books into so-called text parts. And let's see if it works. No, could you start it? There's a little video, fancy stuff. So you will see a bit of fancy stuff at the beginning. So we have collected all the metadata, the authors as they are in the title pages, but then we entered into these books and we checked which kind of texts were really inside. Most of them were not declared in the title pages. So in this way, we dissected these books into text parts. They were, like the Spheros Sacrobosco is a text part, but then there are fragments of other texts. There are commentaries of other text on other texts, commentaries on Sacrobosco, commentaries on the Theorica. There are translations, Latin translation or translations in local tongue. So we dissected these texts in text parts, but also we created a network among them because of this semantic relationship. So one book is connected to another because the other book has a commentary on a text part, contains a commentary on a text part that is in the first book. So in this way, you can think of about a semantic network among all the textbooks, but where the reasons of the links between the textbooks are the single text parts. So in this way, we obviously created a huge amount of data, and you see here, what you see before is all the text parts contained in that book, and then you can go and see when this text part is being reprinted over time. So this network, therefore, has two dimensions. One is the semantic one, is a flat time network. All the books are connected to each other for content-related reasons. One is commentary, fragment, off, and this and that. These are the relations. And the other one is a temporal dimension because these semantic relations evolve over time. And you can have the republication of the same commentary in another textbook, and so far and so on. So this is the way we started working, and we collected all the metadata for each text part as well, many of them, including paratexts. And you know, when you enter into this kind of text, and there are many anonymous texts, and so there are many difficulties that you can find in doing this work. Anyway, so this dissection was made. It took a very long time, at least for the first of the corpora, and then for the others it was much faster also because we entered then into the usage of machine learning to help us, and this speeded up a lot the work. So what did we do? Now I have to show you a little bit some of the major results achieved in order to understand what's coming then. With this kind of thing, so this kind of data, which is really lots of data, then we work in this way. Basically what you see here is a multiplex network, is a mathematical object. The text part is about text part analysis. Each semantic relation is represented by different layers. For instance, here all the books are connected if they contain the same text of reference for commentaries. And here all the books are connected if they contain the same commentaries. So it means that these books then are connected to each other by interlinks between the layers. So this is a multi-layer network. And then we analyze it on a mathematical level. I don't go into this. It is in this paper published in 2019. You can read it. It's a longish paper. And then when we achieve the results, we go back to the interpretative framework and we try to figure out how to make a historical argument out of this. For each dot and each text parts, you can go from here, from this network, directly into seeing the book and reading the text part that we are speaking about. So it's all connected to each other. So one thing that we achieved with this study is the fact that we understood that after a certain point in the 16th century, the content of the books was becoming more and more homogeneous, in the sense that the books were becoming more and more similar to each other. With all these text parts and so far and so on, we have a lot of new text parts coming in, but the books were becoming more and more similar to each other, something that is difficult to see if you don't work with this method, because you can't read 400 books, you can't check all of them so quickly. And what also was clear is that this homogenization process was due to a process of imitation of specific textbooks that they became sort of models. And let's say this process begins by means of the imitation of textbooks that were created in Wittenberg. After there were sort of innovative textbooks, some of them, and they were imitated all over Europe. Wittenberg after the Protestant Reformation. And after Luther and Melanchthon decided that the printers had to move to Wittenberg, so which means not after 1517, but later on, when all the printers of Leipzig were basically obliged to leave and go to Wittenberg and work directly close to Melanchthon. So this is an important result. We will come back to this. You will see at the end why it is important. This is a second study, a little bit more technical, published in scientific reports. But let's say what is important for us to know from this study is that Wittenberg became such a center, such an emanating center, let's say, that books that were previously published somewhere, or text parts that were published somewhere else, if the Wittenberg publishers took them over and they inserted into their textbooks, then they started spreading all over Europe from there. And this for a specific time window of about 16 years. So we can go so precise. And this was a little bit later, is a process that is a little bit later than the one described before. So basically, Wittenberg maintained a complete dominance in the, of the content of the textbooks for about 30, 40 years, and then maintained a very high ranking position, but this ranking position had to be first shared with the Royal Chair of Mathematics in Paris after 1550, especially beginning 1550, but more and more 1560 and 70. And later on, then we have the entrance of the Jesuits and Clavius, and then the thing becomes more plural again. But still, Wittenberg remains very, very important till the end of the whole process. So what you see now here is a sort of historian's view. No, we have all the process from the beginning till the end. We are external. We have the time. The time is in the graphs itself because the books are connected to each other chronologically. So it's mathematically speaking, are oriented graphs. And the reason for the orientation, we are historians, is the chronology. That's pretty easy. But what about if we enter into the network? What about the perception of the actors? So the title of this talk is where the time was ripe for to publish Copernicus. So what was happening around Rheticus or Petreius, the publisher of Copernicus? So for this, however, we need to take another view. And we need to enter into, let's say, the perception of the actors. So here is why did Rheticus publish in 1543? If the focus is in, then we can even think that there was something going on that, let's say, created the chances or not to, or the idea, or facilitated the idea to publish this book, or to this is valid for any kind of event. Now we are speaking about Copernicus and Copernicus book, but it could be, this is a method that it's for any kind of event. And so basically the idea is, can we take a temporal analysis of the dynamic of this network as a form of causality? Is something going on that makes Rheticus more prone to publish, or Petreius more prone to publish exactly in this moment? This picture, by the way, is not in the nice book that we received yesterday in the welcome bag. And indeed, I looked a bit, and it's not Rheticus according to the Library of Congress. This is Copernicus, but it's also sold in Google as Rheticus. So don't take it, don't use it. So what does it mean? This is a much bigger network, but it's basically the same as before, plus many other data concerning economic institutional relationships and between authors, printers, publishers, and so far and so on. This is because of another study. If you're interested, I have a few slides about that, but this is for the discussion. So, but if we take now the actor's perspective, then this network looks like this. It's a network that evolves. So the actors don't have this view. They have a different view. And it could be that there is something going on, and we can see it on a very general level in the dynamic of this network that somehow might point us to specific phases of the life, of the evolution of this network that might be related to the fact that specific events also happen. Let's say, more as a joke, did Rheticus feel a time pressure? There is this nice paper just published, let's say, in front of, in time pressure, with time pressure, people react differently, and it's something that all of us experience, so it was something like that going on in the period. Can we take temporality and temporal analysis of the network as a hint to causality? So I don't think Rheticus was really facing uncertainty in that sense, as in this paper at least. But maybe there was something like an increase, and I will show it to you in a second, not maybe, there was an increase of, a dramatic increase of the dynamic of circulation of knowledge going on exactly at the time around Rheticus and around the publication. So if you see everything, everybody is, I don't know, buying a new car, maybe you are more prone to buy a car as well. So this is the logic behind it. But apart from this, we can discuss, what the point is that indeed we can analyze this dynamic of circulation of knowledge. In here, for instance, this is the timeline at the bottom. What you have here is the publication, is the first publication of text parts, including paratext, literary paratext, and all these text parts were never republished before, after that. So they just, let's say, if you put it in modern terms or marketing terms, they are not successful innovations. No? Nobody cared about them. These are the first publication of text parts that were then republished at least once. And the green part, the green stripe, is the republication rate. So you can see here, the starting about here, there is not only an increase for a little while of new text parts, but there is a huge increase of republication. And this is normalized by the number of books published, of course, otherwise it would be obvious, because you've seen that in these periods many books were published as well. So it means that there is this process of imitation has a huge increase in dynamic. So the people are starting copying each other and republishing way many more times according to this graph. Here you can't see exactly yet which text part, so we cannot really make a very concrete example here. But I give you also a geotemporal distribution. Unfortunately, there are so many text parts that the cities are not placed in the right, geographic space, so you have to take it a little bit in an abstract way, nevertheless. But this will also show to you what's going on in the 30s. So Venice is here, is correct, but other cities, they will be all placed here because it's just too much data to see. So here I put for you the bar 1531 because this is becoming more and more important. So you see how it works here. This is the circulation of text parts when they are republished. And so you have a certain dynamic, and this is still a qualitative way of looking at it, although with this tool we can calculate the speed really and the distances. So you see Paris is in the wrong place because there are too many dots in Paris, too many text parts. But after 1531, so in 1531 there is a little break, and then you see how the dynamic changes. The number of publications is changing, and here the different cities are all, so Frankfurt, Lyon, and so forth. So there is an increase of number of places that enter into this game, let's call it like that, and it becomes huge. And here, of course, the age of the link, so when how long the links are valid also plays a role. So it means for how long a book has been referential or important for another printer or another author to be influencing this printer or author. This is a historical question. In this case, it's set of 50 to 50 years. So a book is, let's say, consider a book remains in the shelf for 50 years. Book historians tend to say 80 years in this time. Historians of science more 50 years for how long a book could have been influential. But so this is we can discuss about this. Now let's have a look at the same again from a different point of view, and this becomes very clear. So this is what's going on in the time. This is the time axis. So these are text parts republished. You read in this way, and this is the age of the link. So when they are republished, so for how long after the first time. So the age of the links changes dramatically after 1531. You don't see, but I can tell you. But there is also another change. The other change is given by the color here, signalized by the color. The color means the same city. So a text part may be a success. These are only the successful text parts that are republished. The others are not here. A text part is republished, okay, successful. But as you see, until this time, the circulation was not really the major point. Let's say an innovation was successful at the level of local market. After this period, there is a huge change in the quality of this dynamic. First is much more, as we have seen before, but all the blue dots is different cities. It means that the local market, the relevance of a local market is decreasing, still there, but the, let's say the perception of a wide geographic area where text parts are republished in the textbooks has definitely changed. So this means it's not only faster, but the distance is also increasing. So this means that the entire dynamic is obviously changing dramatically, and we can take for granted, I would say, that people in Wittenberg, scientists like Rheticus, let's say at the forefront of what was going on in astronomy at the time, were actually somehow aware of this, or they got a perception of this. And so here we enter more and more into the subject. So this is the first point I'm making. There is a difference, and starting from the 30s, especially observing from Wittenberg, Paris, Venice, major centers of production in the 30s and the 40s, this was probably easy to be perceived, that something was different. We can go now slowly back to our historical way of working, and going back to slowly back to close reading, and I will show to you which text parts were mostly circulating. This is pretty easy to do for us to identify them. These are the IDs of the text part. We have a database and so on and so on. This is the timeline, and those at the top are the most republished text parts over time, and the color indicates for how many times in 1 year. So there were text parts that were published 4 or 5 times in 1 year in 4 or 5 different cities. And so let's have a look at some of them, and let's start with the two books that seem to have been changing this dynamic first. And these two books, they are, if you see them, they are not so telling, but they have been eventually so important. These are two books published in 1531 and 1538. The second republished the first, but also adds more stuff. These two books are both published in Wittenberg, as I said. They are both published by the same guy, Joseph Klug. Joseph Klug at the time was one of maybe the favorite publisher for Luther, because he was famous for publishing his songbooks. They were obviously extremely important, as you know. So let's have a look at what they contained, these books. Obviously they contain the sphere of Sacrobosco, one of the fundamental things. Without this, they would not be part of this collection. So what they contain, for instance, is this the most famous preface, I think, in the history of early modern astronomy, is the Melanchthon's open letter to Grineus, which is actually to the students. And this is an apology for astronomy, for studying astronomy, or a request for the students to study astronomy and astrology. But what already this letter also tells, and many people have a bit overseen this aspect, is that they also say, Melanchthon also says, without astronomy we would have a chaos in our history, in our past, in our perception of the past, or the perception of our roots. This will become more and more the subject over time. Let's have a look inside again. So we have the Tractatus de Sphera. It's a bit far for me. Tractatus de Sphera, clearly, this is just a medieval version of it, with no change, just let's say reprint, we would say today. But then we have also little poetry, and this little poetry is 4 lines of Melanchthon, and this little poetry had a gigantic diffusions in all textbooks all over Europe, starting from this point. Exactly like the preface. The preface was reprinted 90 times in any country for very long times, the preface to Grineus. Sometimes the name Melanchthon was cancelled, true, because of obvious reasons, but it was still republished. And this was published sometimes anonymously as well in the Catholic countries. But the main point of this is this little poetry is a way to remember the names of specific astronomic phenomena, which is the rise and setting of the stars of the signs at specific moment, depending on where the sun is. So the heliacal, acronic, and cosmical rising and setting of the stars. And this is a major point to understand. So this is the heliacal, rising and setting, cosmical, and acronic are ways to, let's say, to define the date of specific events. They were used in antiquity, this way of observing the stars, in order to give an hint, to give an indication on which day certain events happened. For instance, today a war started, and then you observe the first star that you can see after sunset on the signs. And with this information, then you will be able to you will be able to know exactly on which day this happened. So this is a very important information. So remember the point of history and reconstructing our chronologies and our past. So this little poetry is an indication. Otherwise, it's a bit difficult to understand. So what I'm telling you is now is something that is exposed after the analysis of everything that I will show to you in a second. But this is very important because these names had to be well known by the students. They are also, this subject is contained in the treatise of Sacrobosco as well, and called the Orthopoetico. And there are examples on how to make this calculation by observing which stars, and then how to go back to the dates. Then we have something new also. This is really new, almost contemporary science. 1531, this is a little fragment of the Epitome of Regiomontano, a very famous book in history of astronomy. Not really a textbook, because the Epitome had only three prints in the early modern period. But this fragment, this proposition, after it was published in Wittem in 1531, was then republished about 90 times all over Europe in the turn of 30, 40 years. If you publish a paper or a book and this is republished 90 times in 30 years, this is really a successful story to tell. So the students all over Europe became aware of this epitome, most probably through this fragment. And this fragment is the explanation of the inequalities of days and night, and basically, then why do we need to deepen the subject? If you think of this, it's obviously important to understand how to calculate when equinoxes, exactly which date of the year the equinoxes would take place. And this is again an important information for calculation of dates and time reckoning. Let's move to 1538. 1538, we have the addition of another text part. Alpharganus is a comeback in this case, is an innovation, but it's also a comeback. Alpharganus is the major source of Sacrobosco, mentioned in Sacrobosco. It was used parallel to Sacrobosco until the 14th century. For instance, Sacrobosco became the major text in the turn of 100 years. For instance, the University of Bologna, for a while, they refused to use Sacrobosco, they used Alpharganus elements. But then it disappeared. Sacrobosco won. This is another story. And Alpharganus comes back in form of a fragment in 1538 in this network of text parts, here with a proposition concerning the visibility or not visibility of the planets, depending on the position of the sun. This is 1538, and all these text parts became, as I said, they were imitated, this book. So all of them had huge diffusion. Some of them a little bit less than others, but all of them are huge diffusion. So here we have again and then we have other text parts here. We have a new preface of Melanchthon together with the other. So we have two prefaces in this book. And this is the letter to Gasser, an astronomer, famous at that time as historian, or a little bit later after this publication, mostly famous as historian because of his chronics of the cities and of different areas. And here is very clear what the point is. The point is, yes, I will get it. The point is exactly the whole point of studying astronomy here, this new edition is to teach the student how to make these calculations, to date past events. And what Wittenberg then does is to not limit itself only to the Latin literature, classic literature, as was in Sacrobosco, but also to expand toward Greek classic literature as well. And here also there is, because of this reason, Rheticus suggested to reinsert, there is another comeback, the Computus Ecclesiasticus of Sacrobosco, which disappeared in the 14th century and came back in 1538, and has a bit of revival all over Europe again. And then a Cisoianus, I don't know if you know what it is. A Cisoianus is sort of mechanical, apparently nonsensical poetry to learn by heart that then will allow you by dissecting the words to make calendar calculations without knowing anything about astronomy. And it's a very interesting tradition, a medieval tradition, and still alive during the Renaissance. And this is the Cisoianus that was circulating in the 13th century in the Saxony, region of Saxony and around in Poland, and this kind of thing. So we can identify which Cisoianus were used. So, and basically this idea of this specialization, calculating past events, became a real obsession. So much in Germany that in the 19th century it was still considered as a science, and there were still dissertations, PhDs going on, and so forth and so on, and became more and more precise, and so the accuracy was, was the point. This science completely disappeared now, but there are centuries and centuries of specialization in this direction, and it is already in Sacrobosco, as I said, but here becomes the focus of all these books, and this spread all over Europe. So what is going on in 1543? Last slide. 1543, publication of Copernicus, clearly, but Rheticus also published another book, another text of him. It's a 30 pages long text, and this is a new version of the Orthopoetico, how to make these calculations with examples from the Greek literature. Some of them, one of them actually taken from Melanchthon's commentary on Hesiod, but okay, they were working together. I think they agreed about that. And the important thing is we are in 1543, Wittenberg is still very important, is that this book was printed together with all the other text paths that we have seen before, and also different things. And after that, it traveled anonymous as an anonymous text, but after that was spread all over Europe. So basically, we can make the hypothesis that the agenda at the university while studying astronomy in the 16th century was rather a practical use of astronomy in favor to support historical disciplines, now to say in a very emphatic way. It was a calendric issue, time reckoning, and no wonder that Copernicus had such a difficult time to be recognized by the European audience as an important book. Basically, it came out while the agenda was changing at the university in the teaching, was changing in a completely different direction. And nevertheless, there was this huge dynamic of circulation of knowledge, which implies that this agenda was eventually interesting for everyone, and implies that maybe one innovation after the other made Rheticus more prone to publish this book finally at this time. We know that it was a long procedure. But somehow the point here is, in spite of the dynamic of circulation of knowledge, is that this book came out in a moment where the general audience were actually busy with a completely different agenda. So to make all these fancy plots and all these kind of words, is a lot of people behind me. I would like to thank them. Even Jochen worked for a while long ago in this project, and so these are all the people in the background of all these studies. Thank you very much.
Thank you very much for this wonderful talk. Thank you very much, and for having shared with us how machine learning can improve our studies in historical research. And now a few minutes for a discussion. Non so se ci sono domande, osservazioni. Giancarlo, prego, se puoi venire oppure ti porto. Okay.
Ma si sente, no?
Ma per chi si
ci sono, scusa.
Sorry but I prefer to speak in Italian because it's more easy for me. Prima cosa, grazie tante di questo grande lavoro che avete fatto, che tu hai coordinato, eccetera, perché conosco tutti i risultati, eccetera. Diciamo due domande che purtroppo non sono riuscito a parlare ieri molto del census di Copernicus fatto da Ginger, eccetera, però secondo me sono delle informazioni importanti che ovviamente, parlando di 470 edizioni, eccetera, eccetera, è difficile raccogliere, ma uno, se avete tenuto conto di versioni annotate da chi era il lettore. Seconda cosa, le immagini, perché non possiamo oramai parlare più solo di testo, ma l'oggetto su cui si lavora oramai è testo più immagine, perché alle volte poi c'è anche il problema di corrispondenza testo-immagine, eccetera, cioè oramai dal punto di vista filologico è abbastanza complesso quello che stiamo andando a studiare. In particolare le immagini, poi sappiamo che ci sono le volvelle, cioè gli strumenti di carta che diventano in molti casi proprio lo strumento d'uso poi di chi era l'utente, eccetera. L'altra cosa è studiare il network della stampa, ma il network invece degli users, cioè di chi lo usava come studio, eccetera, eccetera. Sono due provocazioni pesanti, perché ovviamente un conto è studiare un singolo testo e vedere dove si è diffuso, un conto è studiare 470 edizioni, di cui alcune sono rarissime, per cui probabilmente c'è una sola copia al mondo, ma in altri casi abbiamo migliaia di copie, quindi grazie.
Okay. Should I answer in English? Is it okay if I answer in English so for everyone, so that okay, first point was annotations of students and co in the time. No, we haven't done this work because we have many of our editions are annotated, and sometimes I obviously look at it. And but let's say to make this work on a systematic level and not just case studies, we should first check for all the print runs, how many editions are available, how many of them are annotated, and then collect all of them. So we have taken one electronic copy for each print run, representative for the entire print run, and we have taken the one that was best looking or was for free or whatever. So this obliged us to move on to watch only at what was printed and not what was around. This is a possible work to be done, but this is not a work to be done with computational history. So first of all, the huge work is a collection work. It's a lot of work, and so for the moment I don't see having the resources to do so. This goes together with also the last point. The last point was about the users, the readers, and the many copies of the. It's almost impossible to do a study like this because, yes, as you have said, sometimes you have only one copy left, sometimes a lot of them, but you almost never know actually really how big the print run was. And then there is also the second-hand academic book market. Books were sometimes reused. Books were never, exemplars, were never used. They were never sold, and these are mostly the books that we got because they're clean and nice, and so. Student books, textbooks were used until the very end. So this is and so maybe many of them will disappear just because of the use. We have worked only on not on the readers, but we have worked on the authors and the authors and the publishers and printers, and for this we have published 2 entire books and 2 international working groups working on these aspects. And so this is what you can work systematically. The readers, maybe just looking at the annotation. Then the last point is about images and the relation text images. Yes, we are working on this. It's a lot of work. We have extracted, alone from the Sacro Bosco collection, 36,000 visual elements. This is a lot of machine learning work in the background, and there is a dissertation going on a good part of them in Israel, and other papers. So we have started publishing a bit about this, but let's say we will give the data out when the publications are ready, and especially the dissertation, but we are working on it. And it's very interesting. Some little case studies and so are already spread in our publications. And also we worked also on the computational tables, the numerical and alphanumerical tables. That is where Jochen especially worked on, helped me, and that's a big issue with using an unsupervised AI model that we developed to do so, because we have 10,000 pages of tables alone in Sacro Bosco collection, and no one wants to read 10,000 pages of computational tables. So, and that's why you need AI. But we are trying to publish it right now, so I don't tell anything until it's out.
Just a moment, one question before.
The Volvella forgot, but maybe I'll tell you later, okay.
Actually, I don't know.
But because of the people online, you don't want to, if you don't want to say anything, it's asking it.
No, actually, I have a little question.
Okay.
I was wondering it was very interesting, the thing you said, that poetry, in some sense, was a vehicle for assessing the general role of astronomy in that moment in Europe. And it struck me because it's very likely to what also happened in classical Greece, where recent tendencies in history of ancient science have highlighted how actually mathematics was in ancient Greece some sort of a poetical genre. mathematics itself was conceived very close to poetry in a very broad sense. So it reminded me this kind of analogy, let me say. I wondered if they were, aware of this. If, because as you said, much of the practical task of astronomy in that period was also to recognize, for example, the dates in the Iliad or in the Aeneid by Virgil. So how much were they aware of keeping alive an ancient, let me say, way of thinking about poetry, astronomy?
Very nice question. They were, especially Melanchthon and then Rheticus. They were obsessed by Greek ancient literature. They were, in the 30s, those who knew this kind of scientific literature best in Europe. They were the super experts. I mean, the commentaries of Melanchthon are on ancient Greek literature are gigantic works, and they were, incredibly rich and beautiful. And Rheticus is the one who insisted to teach the students both Sacrobosco and Pseudoproclus both in ancient Greek and in Latin. Because of the fact that you would have to learn astronomy and ancient Greek, otherwise it doesn't make sense. That was Rheticus' point of view. And we have manuscripts of his students, that's why we know all these things. So Pseudoproclus was important. Pseudoproclus, one thing was not so important, but Pseudoproclus alone in the 16th century had about 90 different editions. It's a very important textbook of the time. And so lots of times with the Greek in front, text in front, yeah. Thank you.
Thank you.
What do you regard as the main qualitative consequences, results of your quantitative studies?
Well, I mean, it depends on the time we are looking at. I mean, now I focus very much in the the idea was Copernicus here, so 1543 is kind of an important year. So I watch around this time, and I think that from this point of view is what I just said today. So then this time, clearly the agenda of the teaching astronomy moved into this dating specialization of ancient events, and not as you would expect as now a student of history of science and going from one big name to the other, Copernicus, Galileo, Kepler, and so far. The agenda perceived around it was not even after Copernicus for a long time. Copernicus didn't enter the school curriculum, the university curriculum, until 1630, 1640, and later in many places much later. So that they were, let's say, trying to make something new or trying to work toward what we then called much later on, something like a scientific revolution. What they were doing was studying astronomy with a specific task, and the task was the ancient literature. So this is for me is a qualitative result, because I look at the context. I look at I'm not looking at Copernicus. I'm looking at which kind of scientific culture was circulating and was shared all over the continent, because I think scientific culture started becoming after the 30s also an identity shaping factor for Europe, and that's why I'm interested in these as a qualitative results. Then over time is different. For instance, after the 70s, the qualitative result is what I mentioned at the very beginning in the introduction, is that we assisted the emergence of institutional, very hard competitions between Paris, Wittenberg, and Rome in managing and dominating the scientific book market in Europe. The Jesuits, the Protestants, and the French royal chair, around the royal chair in France.